In this video, we will learn how to do pretension analysis of a bolt. Let's first create the contacts. Go to Analysis, Contact Surface, Bolt Slave. Rotate your bolt slave. Toggle the solid faces. Click the solid faces. Create. This is the mating surface again. Reverse. Bracket master. Create. Now next we need to create a contact definition between the bolt head and bracket one. Here analysis, interfaces, create, contact 1, type is contact, create, add, toggle to C surface means contact surface. Bracket 1 is the master, it will highlight it to white, and slave is the bolt slave. Update. And next you can review your contact surface by groups. Just click on review. Oh, it's not updated. Interfaces, update, contact, update, add, contact surfaces, master. Now review is this. Yeah, contact is created. Now we need to do the rest of the mating surfaces. One is bolt to bracket 1, bracket 1 to bracket 2, nut to bracket 2, and this nut to shank and bracket to shank. We need to create 5 or 6 contacts. Now we will do one by one. Analysis, contact surfaces, nut to slave, contact surfaces, bracket 2, master, interfaces, create, contact to, create, add, contact surfaces, master, bracket 2 is the master, update, slave, update. You can review from here. Review. Contact is successfully created. Contact surfaces again. bracket 1 master 1 create bracket 2 master 2 interface contact 3 create contact surfaces bracket 1 is master bracket 2 we need to rename this bracket 2. This is the slave. Okay, here nut is the slave contact surface nut slave 2 analysis contact surfaces board chunk master create an interference between nut and bolt shank create this is a tie contact is nothing but a bonded contact master bolt shank is the master nut slave 2 is the slave now we have created a contact between nut and bracket 1 to bracket 2 nut to bracket 2 nut to bolt shank and here we need to create two more contacts. When you take the cross section the bolt shank slides on this bracket holes, so we need to create a sliding contact between shank and these brackets. Hide this layer, bottom layer, these two layers. Contact surfaces, bracket 1, master 2, bracket 2, master 2. Switch off, show the bolt. Here contact surfaces, bolt shank, slave 1, bolt shank, slave 2. Now create a contact interface between shank 1, bolt shank to bracket 1 and bolt shank to bracket 2. Go to interface, contact 4, type contact, create, add contact surface, bracket 1, master 2, update, bolt shank, slave 1, create one more contact, add contact surfaces, bracket 2, master 2, bolt shank, slave 2. Here review the contact interface by groups. Right click, review. Contact 1, contact 2, contact 3, eye contact here. This is a bonded contact. Contact 4, contact 5. Here in contact, property type is slide. Just toggle to property ID. PID, create friction. Coefficient of the friction is 0.2. Separation is S. And here discrete is surface to surface contact, and the track is small sliding, and corner is value 0. Do the same procedure for contact 2, 3, 4, 5. Property ID, friction, discrete, surface to surface, small sliding, value, corner value. Property type to property ID, property friction, discrete, surface to surface, track small sliding, corner value. For tie contact, discretization is node to surface contact. And now create a load collectors. Create SPC, no card image, create analysis constraint, select this node, this node, this node, 4 corner nodes, fix all degrees of freedom, constrain all degrees of freedom, and null out card image, create a node, keep 10, yes, SV non-convergence means if the solution is not converged before the converged solution, it prints the output file. NL param, these are non-linear parameters. Created it. This displacement, force, work. NL ADPT, non-linear parameters. NL ADPT. This is maximum time increment. This is minimum time increment. DT max means maximum load increment and minimum load increment in a particular simulation. And we need to create a pre-tension. Hide this header portion. Utility, pre-tension manager, add 3D balls, create a new surface, return, load type force, create new, load magnitude, I am giving 12,000. Actually this is a load magnitude is different for different metal boards. For example, I am giving 1200. Apply. Okay. See, pre-tension load is created here. The final step is create a load step. Pre-tension analysis, non-linear static, SPC is SPC, NL param, large displacement, pre-tension, NL ADPT, NL out, create. Analysis, control cards, next, param cards. Expect NL, keep CNT STP means contact stabilization. If any rigid body moves in the models, it gives some artificial contact stiffness to that contact regions. Large displacement, toggle to 1. Large displacement simulation is activated. Must do the model checker, anything is created properly or not. No failed entities found in the selection. Now export. SPC, large displacement, pre-tension analog. We missed one thing. We need to create a global output request. Global output request. Contact stress. Contact force. Displacement. Stress strain. Format H3D. Now export. Now everything will replicate here. Param and global output request. Export. Finish. Contact was context stress, displacement, chain, stress, everything we requested. Now go to run, Opti struct, solver window, click this and run. There is an error in the material data. Model. Yeah, we have activated mat as well. Switch off this. Export. Now progress is 100%. Now iteration is started. Our simulation. Just now it started. Actually it takes around 20 to 30 minutes, might be. Yeah, it's converging a little bit faster. We need to see. 20% completed. And in the simulation, if it is not converging, we need to check one more thing. Why it is not converging? Open this running directory. Here you will find one more nonlinear pretension underscore nl out file. Open this. See here, if it is not converging, you can find this maximum penetration is 1 e power 10 and maximum residual force is 1 e power 30, like this. Maximum residual force. Now it is e power 7 only. See, maximum residual force is decreasing. Maximum force 4, maximum residual force is 3. If it is not converging, maximum residual force looks like very high, around 1 e power 30, and maximum penetration is 1 e power 10 to 1 e power 20, and maximum pressure also is to be high, and it is showing that this maximum penetration and maximum residual force is acting at this contact 1 interface. And in the low step, maximum penetration error and maximum residual force is happening at contact 2. Due to this load, it behaves differently at different interfaces based on the load path. See here, contact 3 or 50% completed. And in the same directory you can check one more thing, nonlinear pretension.monitor. Open with textpad. Here you can see subcase id, number, increment cutback, converged or not, number of contact iterations, number of equilibrium iterations, number of total iterations. See 7 plus 0 7, 9 plus 0 9, 2 plus 1 3. This is contact iterations and this is equilibrium iterations. This is time or load increment and this is subcase time. Here 0.2, here 0. Now 0.05, now 0.2 plus 0.05, 0.25 cumulative increment. This is total time and this is load factor. This is the displacement, grid and degree of force. You can check its names and definitions over here. Number, increment counter in one subcase, number of cutbacks. If it is not diverging, you will get the cutbacks here instead of underscore mark. If you are doing any nonlinear simulations, you need to check these three files. One is out file, one is underscore nl file, one is monitor file. Or something is cut back here. There is a cutback here, not converged. If the number of contact iterations is 25, more than 25, it won't converge. It gives cutback. Here 25. Maximum residual force is at now 4940. We will check where it is now. 4940. here this region is not converging. We need to check what will happen. Region is divergent. Yeah, after 9 increment it is convergent. C1 is cut back. C2 is cut back to. Here C1 is cut back 1 and C2 is cut back 2. Now 57% of load is completed. And remember, while checking the out file, initially it won't converge. It gives higher number. Force is e power 2 and work is e power 4. Later on it will converge. And here I have included only geometric nonlinearity and contact nonlinearity only. I have not included the material nonlinearity in this simulation. Open the monitor file. Let's see. Total load factor is 92%. Yes, finally our simulation is converged. See here, analysis is completed. Non-linear solution summary for all subcases. Number of increments is 18. Total cutbacks is 2. See here, total number of increments is 18. Number of cutbacks 2 cutbacks. Total number of iterations. See, this is the total number of iterations is 126. Average of iterations per increment is 7. Open the results file. increase this scale factor 10. Yeah, see here, this is a graphical issue. See here, 0 2 3 4 5 6, this is the increments. Here we have cutback rates, that's why it is showing like this. Check the stress, elemental stress. Yeah, expected elemental stress is more of the contact region. And here, and check the contact status. See, 0 means open, 1 is closed, 2 is frozen. Frozen is nothing but bonded. This is the bonded contact, that's why it is showing red. This is the contact area, and this is also contact area. See, usually in the contact analysis, you will check the elemental stress, contact status, whether it is properly established or not, and the contact forces. Means enough contact forces generated at that region or not. And you can check the section view. Go to here section, click this point about x-axis, apply. See how this behavior. See, keep simple. Yeah, pretension is node is acting inwards.